Welcome dear students. Now in this video we will be seeing the last property, that will be the creep. Okay. So dear students, what is creep actually? So this is the deformation of the material. Deformation of the material with respect to what? With respect to time. Yes. At constant load and at constant room temperature, or you can have also the high temperature. Okay, so dear student, this is also known as the slow or progressive deformation. Progressive deformation. Okay, so this is the creep. So this is actually the time dependent deformation, dear students, in the material. It is known as the creep. So if you look at this creep curve, dear students, so here we'll be having the curve like this. Okay, the curve like this up to this failure point. Say this is the failure point of the material. Okay, with respect to, of course, with respect to time, and the deformation in the material, nothing but the strain in the material. Okay, so that will be the initial instantaneous strain. Okay, and dear students, these curves are having the three regions. So this line is actually the straight. So here we are having the creep rate, which is decreasing. Of course, the slope is here, you can see decreasing slope. Then this creep rate is constant and the creep rate increasing, that is increasing slope, you can see here. So dear students, this is the first region, this is the second region, and this is the third region of this creep curve, dear students. So here the first region of this creep curve, you can see here the creep is, or the creep rate is decreasing. Okay, the slope is decreasing. Okay, in the second region, dear students, we are having the constant creep rate. This is straight line. And the third region of this creep curve, actually this creep rate goes on increasing up to the failure. Actually this creep is actually bad phenomena in the material, dear students. So therefore we have to increase the creep resistance of the material. Okay, so how to increase this creep resistance? So definitely by using the high strength and high young modulus material, we can able to resist this creep. So how to increase the creep resistance? So there are different methods, or number one point we can have using high strength and high Young's modulus material. Okay, so definitely high strength materials, high Young's modulus material will not easily get deformed with respect to time. Say next thing, to have this material to be hard and having good strength, you can use the fine grain size or grain structure, isn't it? Fine grain structure material for this room temperature, for this creep resistance. Okay, third thing we can do that at higher temperature. This is at the room temperature, so you can use here coarse grain structure material for the high temperature. Okay, so this is the third thing we can do, or the fourth thing, dear students, we can add some refractory materials or elements to the host material, to increase refractory means at higher temperature, to increase the high temperature strength of the material, high temperature strength of material. Okay, so these are the certain things, dear students. If you know the refractory elements which are having the high melting point, like we are having tungsten, niobium, tantalum, molybdenum, generally all the materials having the melting point more than 2500 degree centigrade. So this is about to minimize the creep tendency of the material or resistance to the creep. So it is, creep is nothing but what? It is a time dependent deformation of the material either at the room temperature or at the higher temperature, and we have seen some of the remedies to eliminate or minimize this creep in the material, right? So dear students, thank you so much.